Like, share, and spread this knowledge, because one day, it might save someone's life. Did you know that when America dropped the first atomic bomb on Hiroshima, only 5 grams of matter were converted into energy? Just 5 grams. Yet the explosion released power equal to 15,000 tons of TNT. Einstein's equation, E equals mc squared, became horrifyingly real that day. Matter turned into energy, and energy into destruction. It was August 1945. The bomb exploded 1,900 feet above the Japanese city of Hiroshima, not on the ground but in the air. The blast formed a massive fireball, a wall of flame stretching for kilometers, its temperature climbing to 7,000 degrees Celsius. That's hotter than the surface of the sun. The shockwave that followed moved faster than sound, what scientists call supersonic. In seconds, it obliterated the city, killing over 70,000 people instantly, and tens of thousands more in the days that followed. Today's nuclear weapons are far deadlier. The Hiroshima bomb was 15 kilotons. Modern warheads can reach 700 to 850 kilotons, dozens of times more powerful. If even one of them exploded over a major city today, the destruction would be beyond imagination. Now imagine this. You see a sudden flash in the sky, brighter than the sun, 10 times brighter in fact. That's the first warning, the flash, and it comes before the sound. If you look at it, even for a second, it can blind you. This happened in Hiroshima too. Children who saw the light lost their eyesight, a condition known as flash blindness. That's why even modern fighter pilots wear special nuclear goggles during exercises, designed to shield their eyes from that blinding light. Because today's nuclear flash can blind anyone within 20 kilometers of the explosion. So what should you do if that flash ever happens? The first rule, don't look at it, turn away, drop to the ground, protect your eyes. But the danger doesn't end there. After the flash comes the shockwave. It moves faster than sound, tearing through everything in its path. Glass, metal, wood, all shattered and hurled like bullets. If you're standing near a window or a doorway, the blast pressure can throw you across the room with a force 18 times your own body weight. That's why during a nuclear explosion, never stand near open spaces. Scientists call this the tunnel effect. When the air rushes through openings like doors and windows, concentrating the pressure and amplifying destruction. Even cars parked kilometers away can have their windshields explode several seconds after the flash. That is the shockwave finally arriving. According to physicist Dimitris Trikakis from the University of Nicosia in Cyprus, who ran 3D nuclear blast simulations using computational fluid dynamics, there are distinct damage zones in every explosion. At the center lies the complete destruction zone. Within 1.6 kilometers, nothing survives. Next comes the severe damage zone, around 2 kilometers out. Buildings are crushed. Then the moderate damage zone, about 3 kilometers away. Structures are heavily damaged, but some walls still stand. Beyond that, up to 5 or 6 kilometers, lies the light damage zone. Windows shattered, vehicles overturned, but survival is possible. In those computer simulations, even in the 750 kiloton blast models, some blue-colored buildings appeared to survive. Why? Because they were underground or surrounded by concrete. Basements, inner rooms, reinforced shelters. They absorbed the pressure. Wooden structures did not. So here's what scientists concluded. If you want to survive a nuclear explosion, your best chance is to be in a concrete room, away from windows and doors. A basement is ideal. When the explosion happens, you have only 8 to 10 seconds to act. Get inside. Close all doors. Go to the deepest windowless part of your home. A storage room, a pantry, even a bathroom. Anywhere away from openings. Concrete walls will shield you from radiation better than wood or metal. And that's important because after the blast comes radiation fallout. Dr. Dylan Spalding from the Union of Concerned Scientists warns that radioactive fallout, tiny particles of dust and ash carrying gamma radiation, can spread tens of kilometers from the explosion site. Alpha and beta particles don't travel far, but gamma radiation penetrates deep, through walls, skin, and bone. Only thick layers of concrete, earth, or dense materials can stop it. That's why in countries like Switzerland, Norway, and Finland, Every major building has an underground fallout shelter. In the US, Cold War-era bunkers still exist, stocked with food, water, and air filters. In Pakistan, India, and other nuclear-armed nations, experts are now urging citizens to build underground safe rooms. Just one in every house could save thousands of lives. A proper shelter has a few key features: 1 or 2 entrances, never more. Thick concrete walls, no windows. A small sealed ventilation system for clean air. And most importantly, keep the space filled, not empty. Books, furniture, and sandbags absorb radiation and shock pressure better than air. If you ever find yourself in that nightmare, the flash, the blast, the roar of the shockwave, remember, the first few seconds decide everything. Turn away. Take cover. Get underground. Stay inside for at least 48 hours. Wait for official alerts before stepping out. Because after that first explosion, the real killer is often the invisible one: radiation. Today, the world's nuclear arsenal contains bombs hundreds of times stronger than the one dropped on Hiroshima. In the wrong hands, or in the chaos of war, one detonation could ignite a chain reaction that changes life on Earth forever. But knowledge is power, and preparation can mean survival. So, learn the science, share the awareness, and remember, the line between life and death, between fire and survival, may just be a few meters of concrete.